Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we have another banger of questions waiting for us. So let's get started. Yo, so today we have these things. Count the number of complete components. So again, like Leetcode when is going to start up, basically want to nurture a particular topics. They are on consecutive days, basically give the similar type of questions. So that is the beauty of the question. I also feel that is actually helpful also because your entire topics, like the variety of question and the most difficult question to the very known popular question, everything is going to be revised on the same go. Yeah, so I think that is the graph question they have started asking from last 2 to 3 days back. So today's one also on the same path. Yeah, that's the things. So now let's try to understand the question first. So they have given us an integer n. So that is very standard things. They will definitely give you an integer n, that is the number of vertices that can be possible, and there is an undirected graph with n vertices, that we are for sure because every vertices is from the range of 0 to n-1, as simple as that. So they are given an integer n, how many number of vertices is going to be allowed to this graph, and they are mostly are zero index based things, like they are numbered from 0 to n-1 node we have it in our graph, and they are also giving us a 2D integer array that we are seeing from last 2 to 3 videos. That's so they are giving us for sure. So ages of I represents there is an age from AI BI denotes there exists an undirected graph. Now this time they have given even undirected graph. Directed graph means if there is an age from A to B, so from A you can go to B, but from B you can't go back to A. But if that is an undirected graph, you can go from A to B and from B to A. That's the thing. Now what we have to return the number of complete connected components of this graph. So we have to return the number of complete connected components. Now let's understand what is actually a connected components altogether. So a connected component is a subgraph of a graph in which there exists a path between any two vertices. So where they are stating there exists a path between any two vertices. If you on a particular subgraph, so in that is a particular subgraph, that is a subgraph altogether, and if you choose any two vertices, there is a path between them. If you choose 0 and 1, yes, there is a path. If you choose 2 and 1, yes, there is an edge. If you choose 0 and 2, there is an edge. So that is the connected component, but there is no vertex of a subgraph shares an edge with a vertex outside of the subgraph. So this is a subgraph. Now 5 is altogether a subgraph, 3 and 4 is altogether a subgraph, but it should not share any edge outside of its boundary. So this component will not share any edge to 3 and 4 wala component. It will not share any edge with 3 and 4 wala component. That is the things of a connected component. I think components I already told you, like connected components or components is basically a particular group a particular portion of a subgraph which is isolated from other particular subgraph, other particular portion of a graph. So these are isolated chunks of subgraphs, and they have given the entire graph, and the entire graph can be built by isolated chunks of subgraphs. So in this example you can see like 0 1 0 2 1 2, and if you draw the entire graph, and 3 4. So here you can see the node number we know from 0 to 5. Is there any entry for node 5? So that means node 5 there is a no incoming or outgoing edge, and for others if you draw the things then you will get this picture. So that is the graph is given to us, and that can be you can say that is a subgraph type of things. There is a multiple subgraphs altogether. Now that is the connected component we understand, but they are asking us to complete connected component. Now what complete stands for? A connected component is said to be complete if there exists an edge between every pair of its vertices. So if you can choose any two vertices, there must be an edge. So that means that is a like mesh type of things. So every node is connected to all the other nodes. So that is the star format graph. So if you choose any node, so if you choose node 0, what is the other node in this particular subgroup? 1 and 2. So there is an edge from 0 to 2. There is an edge from 0 to 1. That should be bound to be happen, right? And now, so on this discussion, how many complete component we have we have 3 that we can easily visualize. And on this example, if you draw the graph with this particular example, you can see the picture is something like this, but here answer is 1, because that is the complete connected components for sure. But on the other hand, the component containing vertices 3 4 5 is not a complete, since there is no edge between vertices 4 and 5. Thus the number of complete connected components in this graph is 1. So as we already told, complete means if you choose any node, it should be point to, you can reach to any other nodes, all the other nodes of this particular sum. So from 4, is there is a direct path to 5? No. So that means this particular things, and vice versa also going to be true. So from 5, is there is a directed path to 4? No. So if that is the case, so that means this particular subgraph is not a complete component. So that's the things. I think question is very straightforward. Now it's boiled down to like how you can do the implementations. Yeah, so I am just quickly give you what I am able to think of this, and if you can look on the constant also, like you can see that is very small. Like your node can grow at max of 50 only, at max of 50 only. Yeah, that's the things. Now let me just think on your own first, guys, because that is the medium level question, and I personally feels that is quite easy on graph topics if you face this question, and if you know standard graph traversal algorithm like BFS, DFS, then you should be able to solve this with some slight to like very slight minor modifications on your BFS or DFS template you guys are following. Yeah, so just you need to know how we basically do a traversal of a graph. That's the things. Other is very simple. So yeah, so I am assuming you know BFS, DFS, and if you don't know, and if you want me to make a video of the BFS, DFS, please do the comments. I am not going to explain how BFS or DFS actually work on this particular video, but I am giving what's the extra modifications I basically put on my BFS template or DFS template you guys are following. What is the extra modifications, or what is the extra basically this question specific incorporations you have to do on your template to solve this question. So if you running a BFS, if you running a BFS, so you obviously taking a note to for sure. If you are taking a note to for sure, and what basically I am want, if you have this BFS, or I like to name it as a helper functions. So whatever the functions you took, whatever the functions you are using, what is the functions you are using, I want your function should take a node as an input, and your helper function is capable enough, should be capable enough to return a list, Now what's this list? In this list I want it should cover all the node n1, n2, n3, all the nodes you are able to visit starting from whom? Starting from node named node, because we taking node as an input. So starting from node that we are passing to our as an argument to our function, your function should be capable enough to return this list, What is the node we can visit by doing the BFS to this particular starting from a particular node. So can I say if you able to return me the list, so can you say one portions we already solved. Which portions we solve? They are connected component. So the list, all the list in this particular node are connected component, are connected to each other. That's the for sure. Now we have to check, are they completed? That we don't know, that we need to check. Now how you can check? So if now the question is boiled down to very simple. So if you have entry A1, A2, A3, A4, so that is the list after the BFS you got. So it basically hold all the node. Now I am asking, are they complete? So complete means this node should connect to this and this, all three, except this node should connect to A2, A3, A4, and A2 also, and we know as the graph is undirected, na? So if A1 to A2 is an edge, then we know A2 to A1 is an edge, A3 to A1 as an edge, A4 to A1 as an edge. So we just need to check on the forward. If from A1 we are able to satisfy there is an edge to all the rights, then that means starting this node is valid following complete property, following my complete property for sure. Now again you are going to check from A2, is there is edge, and there is an edge from A3 to A4, like A2 to A3 and A2 to A4. Similarly from A3 to A4. If all such connections are exist to your graph, can you say it's a complete graph? It's a complete property also true. Complete property is also true. But any of them on your A1, A2, A3, A4, if let's suppose A1 to A2 is there, but A1 to A3 is not there, so can I say on that particular time itself I am returning this particular component. This particular component is not a complete component, not a complete component, not a complete component. Yeah, that is the like extra things we have to do, and otherwise that is just a very standard implementation based question, how you can efficiently implement the things. Yeah, that's the extra things, extra like iterations or extra modifications you have to do on your template. Otherwise I think we should be great. So now let's go to the code only. So as you know, like I am prefer to define my graph with default tick of in generally I took it as a list, but on this particular question I took it as a set, and the reasons I am going to tell you on the future why I took as a set not list. And as you know, like we are iterating to our edge, and as we know that is an bidirectional edge. From graph U to graph of U we add V as an because U V connected, and from V to U also there is an edge because that is undirected. So if you can go from U to V and from V to U, you are also able to go. You are also able to go. As simple as that. And then we have defined our visited array, visited default. That is very standard things for BFS we have to follow. And now that is our helper function. And guys, please comments like if you not able to understand of any particular portions, that is very standard graph creation things. That is very standard graph creations things. That is very standard BFS things on the graph. If you not aware of these particular things, I personally feel I basically need a separate times to create on video on this particular topic. But if you guys are not comment on the video, then I am assuming that you guys are already aware of this particular thing. So please do comments what particular portions you are not able to consume, and if you like any particular portions, then also you please do the comments that these particular portions has very good explanations. Like make this comment so that I am able to understand what particular portions I need to improve, what particular things I need to make videos on the future. Please do. That is basically help you also and my also to create contents on which particular things you guys actually need. So I am assuming that graph creations you guys already know. So this I am assuming, and this is very standard BFS. I am assuming this you guys are already aware of. But if you're not aware on it, I will be more happy to make a video on this particular topic. So please do the comments. Yeah. So now go to the helper function. So helper, I'm basically like to make it named as an helper, but you can that is BFS only. So as you already aware, like if you are following us in last 2 to 3 videos, we are define our queue with DQ. Why DQ? That I already told on yesterday's video, and we are appending queue.append to the node that is passed to you. So I already told. So I am providing you a node, and you should be able, your function should be able to return me a list. So this list means starting from node, what all the node I can visit, what all the nodes I can visit. So if we are able to make so, if I am going to return you the list, so that means this particular all the node on this particular list, all the node on this particular list are connected. Are they complete? That we will check. Are they complete? That we will check. But initially we will try to make what are the connected components. So and I have initialized vis of node to 1, and I am amending this particular connected list. So this is actually the list I am going to return from final function. So this connected basically point what is the node I am able to explore starting from node. So I am initially at node, so I am amending node to my connected, and then I am doing here very standard BFS, very standard BFS. I am not going to explain, that is very standard BFS template. And what is the extra things I have added? If this particular, when I am pushing to my queue, when I am pushing to a particular node which is unvisited to my queue of to my BFS queue, that on that time I am also pushing to the neighbor node to my connected group also, because that is this particular neighbor node also we are able to explore. And finally I am returning my connected component. Now I have initialized my answer, and I am iterating from I in range n. So as we already know, we have n vertices. So we are iterating from 0 to n minus 1, and we are checking if a particular node is unvisited. So that means that is altogether this particular node is altogether a new subgraph portion that we not aware of, that we still not visited. So why not we are calling our helper functions to explore all the node we can visit. We can visit starting from this I node. So these particular things that is also a very standard things of determine how many components do we have in our graph. So we are basically iterating a for loop, and every for loop we are basically checking if this particular node is altogether visited or not, then we are performing an operation. So how it is basically work, if when you are at 0 so from 0 if you call your helper, you are able to make 1 and 2 also in visited. So when your next iterations loop is going to for I in for your loop is on 1, so this loop, these conditions is altogether not going to be satisfied, and your for 1 it is not going to enter on this particular block, because from 0 when we run a BFS from 0, because 0 is not visited, this 1 and 2 also going to be visited. So this loop again going to be run, this particular logic is again going to be done from 3. 4 it is also not going to be done, because when we are called from 3, 4 is also going to be visited by the helper functions, because here you can see we are marking visited to our neighbor node. So that means all the node we are able to visit. That is very standard things, guys. That is very standard. What is the number of components in a connected the number of connected components in the particular graph. That is very standard things. I am just writing the same things, and here I am just doing the standard BFS. Only with extra things I should be able to return the number of connected components we can visit. That's the extra things. And when you call your helper, you are able to get your connected list. All the node that are in the connected group starting from node I, and I have take its length, and I am making a boolean OK equals to true. Now where we are using this OK equals to true, I will explain. Now you have this list. Now what you need to check? You need to check every pair has a connection. Every pair has a connection that I already explained on this particular one node. In these things now we need to check these particular things we need to check if you have this list. So how we can check? So we are iterating nested loop for sure. So from A1 we are going to check A2, A3, A4. From A2 we are going to check A2, A3, A4. A3 we are checking A3, A4 like this way. Why not reverse we are going to check? I already told that is an undirected graph. So that's the reasons I am not going to check the reverse. So exact same things I did. For j in range ln is the length of the connected list, and from k we are starting from k in range j plus 1 just of the right to ln, and I am checking if my connected of k. So what is the vertex? Vertex is the, because j and k are the indexes, so connected of k is the vertex, is not in my graph of connected of j. So connected of j is the vertex, and graph of this vertex is giving me the list, giving me the set of vertex from where there is a directed edge, from this j. So that's the reasons I have initialized my default dict as a set, but usually I do to list, but here I have initialized to set, because checking on a set, again here we are checking on a set. So checking on a set is going to take off a big of one time, but if you are defining is a list, then it is going to be taken big of n, again big of n. And here you can see we are running a kind of n square type of complexity, and if you write another things, that this particular group is altogether kind of n cube. So here we have optimized by defining our graph as a default dicta set. So that's the reasons I put it as a default dicta set. And if there is not a edge from connected of k, from that is the vertex to the vertex connected of j, if there is not an edge, then we are making our booleans to be false. That is our booleans initially we have defined. So considering that all the node on this particular connected components are complete. So we initially thought let's make it complete only on the initial go, and this particular for loop is going to change the booleans, is override the booleans if there is an complete rules violation. So here we have a complete rule violation, so we are overriding our boolean to OK as false, and we are breaking. And on outer for loop also, when there is an OK equals to false, we are also breaking our outer loop, because if any two particular vertex is not together satisfy the complete functionality, then we don't need to check further, we can break the entire things from there only. So now if this entire for loop is going to be executed and still our OK is true, so that means this particular components that we just fetch from our helper call is complete also. So we are increasing our answer, and finally we are returning our answer. Yeah, so the question is I think that is question is very simple on if you know standard graph traversal algorithms, that is just basically how you can efficiently implement the things, that basically the motto they want to test this particular question. So let's just quickly discuss the time complexity of this particular question. So time complexity, I have to say here basically we are doing the most rigorous things, that is of big of n for sure, and this helper functions is going to a BFS, and you know the BFS complexity of big of v plus e. What is the v on our case? V in our case is at big as like 50, and v plus e, so 50, so kind of n square you can say, like h can grow at big as n into n minus 1, so maybe we can consider as an n square. So this is like v plus e, so n square plus n kind of complexity. I can write it as an n square only. And then what we are doing then again, like, so that this is going to be common for everyone. So this n square plus this n square is going to be happen from here, and here basically again that is a quadratic complexity. I can write it as a term of n squared only, n squared only. So yep, that is the time complexity, right? So here basically two nested for loops are going to be iterated, and this is going to be, we are able to make it to work as a big of one complexity because we are using set. So that is the time complexity mostly for this particular questions, which is boiled down to be how much? That is of twice n squared, that is of twice n squared into n. So kind of big of 2 raised to the power n cube kind of complexity. So that is the complexity of on the time part. And on space part also we have some hit on space because we have defining our graph, and defining our graph is kind of big of v plus e, big of v plus e to or I have to say like, yeah, big of v plus e, because we are basically taking all the entry of the age also. So that is kind of n square to basically initialize your graph. And not only that, we are also using this connected wala things, connected list. So that is also going to be take as a big of n, big of n. Yeah, so that is on the space part, that is on the space part. And on time, if you can put 50, so 50 into 50 into 50, how much? 50 into 50 into 50, that is of 1 2 3 4 5 1.2 into 10 to the power 5, 1.2 into 10 to the power 5. The complexity is something like 1.2 into 10 to the power 5, this into 2. So that means 2.5 into 10 to the power 5. So we are quite in range of time complexity. So yeah, the submissions also like took only 67 milliseconds to execute. So yeah, on time perspective, I think that is the most optimal solutions. But if you guys are able to pinpoint any of the optimizations we can put, please do the comments. I will be happy to make some modifications to my code, and I will maybe update my templates to share with you. So that's the things, that is I personally feel that is the most optimal solutions for these particular questions. We definitely need an big of n cube type of complexity, because that's the reasons the n is very small, and my solution is altogether like a faster of 95% of the submission. So I think that is the solutions that they are basically looking for. But if you are able to pinpoint any more modifications, then please do the comments. I'll be happy to do the modification. So that's it guys, that's it for today. So if you are able to understand the entire solution, please do subscribe to our channel, and please share the videos to your friend circle, to your connections who are basically preparing to like you for new product based companies, and they are on the plan of switching. They are also exploring, they are also making their problem solving brush ups. So please share the videos to the people who are basically need these particular videos, need these topics to get the things revised. And please subscribe to our channels, and please turn on the notifications because we are going to be again try to be live with a new questions on tomorrow also. So bye guys, bye for today, bye, happy weekend.